Okay, so let's continue on and talk about piecewise defined functions. So some functions are defined differently on different parts of their domain. So one useful way to think of the absolute value function is as a piecewise defined function. So here's our absolute value function. So think about that. This is a piece of the line y equals negative x, and this is a piece of the line y equals x. So the function changes its definition, so defined, changes its definition at x equals 0. So on the interval from negative infinity to 0, the function is defined as f of x equals the opposite of x. So remember, f of x and y interchangeable. And on the interval from 0 to infinity, the function is defined as f of x equals x. So I drew the graph already, so let me write how we write a piecewise defined function. And we say the f of x equals x if x is greater than, and 0 needs to be included in one of these, greater than or equal to 0. So that says this dot is hooked to this piece of the line, and that's this definition of the function. And then it's the opposite of x if x is less than 0. So this is representing y equals negative x, and this is representing y equals x. Okay, so let's try graphing some of these. And here's a function that's defined in 3 different pieces. And so I usually, I'm going to start by labeling my axes, of course. And then I'm going to use green, so hopefully you can see that better. So I look at the part about where how x is being chopped up before I start. So this says if x is smaller than negative 1. So here's x equal to negative 1. So this is talking about x values that are smaller than negative 1. So I want to graph y equals negative 3x for x values that are smaller than negative 1. So if it helps, you can even make a little xy table like you used to do in beginning algebra and say, well, how about if x is negative 2, then y is 6. So I know the point negative 2, 6 needs to be a point on my graph. And then if I do negative 3, I'm going to get 9, and that's not even going to fit. Well, I guess it is going to fit on my grid. If I do negative 3, 9, there we go. Okay, so I know it's a straight line. And then when x is negative 1, I would have y is 3, but the function is not defined as being part of the line at that point. So this is not a point on this line, and it may or may not be included when I get to other parts of the graph. So then you draw a straight line connecting your points to the circle dot that indicates that one single hole has been punched out of the graph. Then the next piece says if x is equal to negative 1, then y is equal to 0. So that says make a solid dot at negative 1, 0. And then it says for x values greater than negative 1, y equals 2x squared plus 1. So it needs to start being that graph when x is negative 1, but that point is not a point on the graph. But we can see that it's the same open circle we already have, so we don't need to make another open circle. But let's see where the graph goes. If we put 0 for x, we're going to get 1, so the point 0, 1 is a point on the graph. and then the point 1, 3, 1, let me try again, 1, 3, and then 2, 9. So this is a piece of a parabola. And it needs to start at -1, 3, and then go down to hit that green dot, and then back up. So this is a parabola with a hole punched out of it. And then instead of that hole being on the graph, the point -1, 0 is the point on the graph. So then if we're asked to evaluate piecewise functions, we say, well, let's see, what is f of -2? You look at x equals -2, and we can see that the point of the graph, the y value is 6. So f of -2 is 6. Then f of -1, you look where x is -1, and you say the y value is 0, because that's where the solid dot is. The circle hole is not a point on the graph. And then f of 0 is 1, because this is the part of the graph that you're looking at when fx is 0. Okay, so you can pause that, rewind it, try again, do it yourself. That would be a great exercise. Okay, so here's another one. It says if x is between -3 and 0. So I think of the graph as being divided up into vertical strips. So in this strip, y equals 2x plus 5, which is the graph of a line that I know how to draw. Okay, so then when x equals 0, it says y is -3. So the point 0, -3 is going to be a solid dot point on my graph. Let me label my axes. And then for positive values of x, so that's all the values of x to the right, then I'm going to have y equals -5x. Okay, so let's start where x equals -3. And when x equals -3, y is -1. So we know that's a point on this graph. And when x is -2, we get +1. Or you can just use the slope of 2 to make the next dot and the next dot. But when you get to x is 0, make sure that you make that an open circle, because the function is already defined as -3 at that point, and a function can't have two y values for one x value. So we have this piece of a straight line, so we call this a line segment. And the graph doesn't exist for x values smaller than -3. And then let's look at where the graph goes if I have the y equals -5x part. And at 0, we would be at 0. So there's an open circle at 0, 0, where the graph would start, but it's not defined there. And then when x is 1, we'll get y is -5. And then when x is 2, y is -10. So from the open circle, we make our straight line, and this time it needs an arrow on it because it keeps on going here. So on the left, that piece doesn't keep on going, but on the right, that piece keeps on going. So let's talk about the domain here. So the domain is all the values of x that have values of y on the function. So -3 is included. There's a point on the graph there. 0 is included because there is a point on the graph. And then it keeps on going forever. So we never put is less than infinity. And in fact, I was just writing it this way for it to make sense matching up to the domain shown in the piecewise definition of the function. But usually you write the x on the left and say x greater than or equal to -3. And then you can write that in interval notation. So these all mean the same thing. So that's the domain. Then the range, well, I can see I'm down at -infinity. And then as I'm coming up, I'm looking at y values and saying all the y values are included up to 5, but 5 is not included. So only y values smaller than 5 are represented on this graph. So that's the find the range from the graph. Then locate any intercepts. The only intercept is 0, -3. So look at the x-axis. Do you see any points on the x-axis? Oh, there's another one here that we need to find. And then look at the y-axis. And here is the y-intercept. So let's see how we find this x-intercept. If y equals 2x plus 5, and I want to find the x-intercept, I set y equal to 0. And can you see that x will be -5/2 then? So -5/2, 0 is an x-intercept for this graph. And then is f continuous on its domain? Well, no. If you can't draw it without lifting your pencil up, it's not continuous. Okay, so another good one to practice on. So now these last two, these are really, really good practice problems, and I want to take some time with them. So I'm going to break the video again here and continue it in another new video.